Hello and welcome, fellow coders. After the last few tutorial videos have been mostly dealing with variables, I am happy to announce that we are finally getting into the more fun topics. And today we are going to talk about functions. Functions are everywhere in Go. If you have watched any of my previous tutorial videos, you have seen that I already used a couple of functions like the main function or the printline function. That is because it is basically impossible to explain programming in Go without using any kind of functions. Even though they are so heavily used, the basic concept behind them is pretty easy to understand. Just like the human body, you put some things in and you get some things out. I'm talking about energy. Obviously. And functions work the same way. You put some things in, called arguments, and then you get some things out, called return values. And much like in Vegas, whatever happens in functions stays in functions. Okay. As you can see, we are starting with an empty main function. This will help us understand the basic syntax of functions. Every function declaration starts with the func keyword, followed by a space and the name of the function. In this case, the function is called main. Right after the name we have two parentheses. This is where we can define parameters the function will expect. I will talk about that a bit later in the tutorial, so do not worry that they are opened and closed right after. After the parentheses we have an opening curly bracket. This indicates the beginning of a function body, whereas in the end of each function we have a closing curly bracket indicating, well, you might have guessed it, the end of a function body. As I already told you in the first video of this tutorial series, the main function is the one that gets executed as soon as you run the golang program. So if I run go run main.go and execute it, you can see nothing happens. Now let us define a new function called sum. First the func keyword, next the name sum followed by two parentheses. This time though, we will pass in parameters into the function. Since sum will be calculating the sum of two numbers, let's use two integer variables called a and b. All parameters for a function need to be separated by a comma. So if you want to add a third parameter, it would look like this. One cool thing about Go is that if you have parameters of the same type, like for instance 3 integer values like I have right here, you can omit the type of all parameters except the last one. The compiler will recognize them as integer values as well. Even if you add a parameter of different type in front or after all integer values, the compiler will still know that a, b and c are integer values as long as you keep all integer values together and the last one has the type. But for now our sum function will only add two numbers. The function body is again encapsulated by curly brackets. So all the code within these two curly brackets will be executed as soon as you call the function. For now, let's simply use the printline function of the format package to print out the sum of both values. Within our main function, we can now call the sum function. As you can see, my IDE already tells me that the sum function expects two integer values. Let's use 3 and 4 and see what we get when we run our main function. Okay, cool. Now we have defined our very first function. Before we go any further now, I would like to draw your attention to the wording. The moment you define a function, everything within the parentheses are called parameters. But as soon as you call the function, the values you pass into the function are called arguments. Make sure to keep this in mind. In some cases you want to work with the result of a function. So for instance you would like to call the sum function, store the result in a variable and then do some more calculations with it, and in the end you want to print it out. You can see that my IDE underlines the function red, meaning that I cannot assign the result of the function to a variable. But fear not, of course Golang has us covered. Functions can have so-called return values. If you want a function to return something, you need to specify the type of the value you want the function to return. In our case, it is an integer value. So to specify that our sum function is going to return an integer value, we can write in between the parentheses and the opening curly bracket. This whole line, beginning after the func keyword up to the opening curly bracket, is called a function signature, just for you to know. You can now see that the curly red line has disappeared in the main function, but instead it is now under the closing curly bracket, telling us that the compiler is missing the return value. So instead of printing the result out, we will now use the return keyword to return the result. Now that the compiler is happy, let's run our code and verify that it works. Yep, it prints out 7. That is because we store the result of the first sum call in our result variable r. Then we call the sum again using r and 5, omitting to store the result. This means that the returned value of the sum function will be neglected. And lastly, we print out r, which is still 7 from the first call. If we now store the result of the second sum call in our variable r and run the code again, we can see that now r has the value of 12. Functions can actually have multiple return values. Let's rename the function to calculate and define 4 variables in our body. S holding the sum, D holding the difference, P holding the product, and lastly Q holding the quotient. Now, if I want to return all of them, my IDE shows me that the function wants me to return one value, but I am actually trying to return 4. In order to do so, we can do that by adding more return values into our function declaration statement. But the return values need to be surrounded by parentheses. Now the function is working fine. But if I go back to the main function, remove all this old code and try to store the result of the function into the R variable again, we can see that the compiler tells us that it cannot initialize one variable with 4 values, which actually makes perfect sense. Since our function now returns 4 values, we also need 4 variables to store our results into. Let's call them S, D, P and Q. And of course, let's print them all out to see that it actually works. Okay, nice. One thing that you will see a lot when writing Go code is that functions will return an error as their last return value. This is a common practice when writing functions. It will indicate to the one calling the function that something unexpected has happened or that invalid arguments have been passed. For instance, if you would have tried to divide by 0, in that case the error would tell us something like unable to divide by 0. So if you see an error as one of the return values, always be aware of that. The error variable will, or rather should always not be nil if something within the function went wrong. And it is also a best practice that the error is the last return value. Okay, we have already covered a lot of ground. We have learned how to define and use functions, but we can do so much more with them. We will see that in Go, functions are so-called first-class citizens, meaning that functions can be used as parameters, return types, and that they can be assigned to variables. That is pretty awesome and allows for some really cool tricks. But first, I need to explain what anonymous functions are. Anonymous functions, in contrast to regular functions, do not have a name. Both functions that we have defined so far had a name, sum and calculate. But we can also define functions without giving them a name. Let me quickly get rid of all this code, I do not need it anymore. Now within our main function we can simply use the func keyword, followed by a parameter list, a and b of type int, a return type, which we neglect for now, and lastly the function body. Within our body, let's just print out a plus b for now. But if you write it like that, the compiler complains that our function is not used. And not used for functions means not called. In order to call a regular function, we write down the name followed by arguments in parentheses. This time though, instead of the name we have the definition. So we can use parentheses right after the function body to directly call it. Let's pass in 10 and 2 and run our code, which prints out 12, perfect. Another thing you can do with anonymous functions is to assign them to variables. If we assign this function to a variable sum, we can see that sum is not used and more importantly, that sum is an invalid type. But if I remove the argument list, you can see that the compiler is not complaining anymore. This is because sum now holds the function as its value. What I cannot do is use that variable without actually calling it. If I try to use the printline function passing in the sum, I get an error. And same as before, in order to use the function we need to call it. So let's call it. Remove the printline statement and call sum using 10 and 2. Running this code now prints 12, as expected. Cool, right? Anonymous functions, as explained before, can also have return types. So if I, instead of printing the sum out, want to return it, I need to define int as the return type of the anonymous function. Then I can store the result of the call into a variable r. If we run this, again, we get the result 12. Okay, let's quickly go over it. What we have done here is defined an anonymous function which returns the sum of two parameters. We have stored it into a variable sum and called it later. So remember, a function without a name is called an anonymous function. We will use that later on. Now let's have a look how we can use functions as parameters to other functions. To show you that, let me first clean up the main function and then I need the sum function from the beginning. So let me quickly paste it from my notes. Let us now write a new function and let's call it calculate again. The calculate function should take another function as a parameter and in the end return an integer value. As for the function we are going to pass into the calculate function, you might have already guessed it, it will be the sum function. So let us now get over how we can define a function as a parameter. Same as for an integer value, we can define a function basically in the same way. First the name of the parameter, let's call it f for function, then instead of the integer type, we define a function using the func keyword. As we learned before, every function has a parameter list, so we add the parentheses. Our function will take two arguments itself, so we need to define two integer values a and b as parameters. And as I said before, the function should return something, so we add int as the return type. I know this might look a bit weird, but as soon as you use it a few times, you will get used to the syntax. In the calculate function body, we can now call the function f and return the result. But now we have a problem. F takes two parameters, so we need to pass them to the calculate function as well. In our main, we can now call calculate and print out the result. We can see that the first arguments are a and b, so we pass in 10 and 2 again. And as for the third parameter, we can now pass in the sum function and again use 10 and 2 as arguments. That's strange. Why is the compiler complaining? Okay, I have to admit, this is a trick question. Pause the video and try to figure it out for yourself. Do you have it? Okay, let's go over it. If I hover over the sum function, the error message makes it pretty obvious. It states that I cannot use the result of the function, which has the type int, as an argument of the type function. By passing 10 and 2 to the sum function, we are actually triggering a call of the function. So the body will be executed and the integer value will be returned. Hence the cannot use the value of type int error message. In order to pass in the function itself, we can simply remove the argument list and now only the sum function will be passed. The actual call of the sum function will happen within the calculate function. We can now run our code and here we go. 12 gets printed out. Awesome. If we now define a subtract function the same way as our sum function, but instead of the plus operator use the minus operator, we are able to pass it into the calculate function. This works because calculate takes a function with a specific signature. It needs to have two integer arguments and must return an integer value. We can pass in every single function that has this exact signature. We can even use an anonymous function on the fly like this. Let's just simply multiply a and b and return their product. If you run our code, you can see that calculate now gets executed 3 times and calculates according to the passed-in functions. Pretty awesome, right? We have seen how we can use a function as a parameter to a function. Now let us talk about functions as return values of functions. For that, let me define a new function called timer. It will take an int64 variable of name start as its parameter. And for now, let's leave out the return value. Within our function body, I will now define a new anonymous function and store it into the variable f for function. This function will take no arguments but return an int64. In its body, I will define a new variable called end and store the current time into it. Golang provides us with an easy way of dealing with time values within its time package of the standard library. So we can type in time.now to use the now function of the time package. We want to have the timestamp in milliseconds, so we can call the Unix milli function right after. Do not care about how this exactly works. What it returns is the current timestamp in a specific format, which is an int64 value. Now what our function will return is the difference between the end timestamp in milliseconds and the start parameter, which is an int64 value as well. That is it for the anonymous function, so let's return it. But to do that, we also have to specify the return type of the timer function, which now is a function with this signature right here. So we use exactly that signature in the return type. Okay, the compiler is happy, but I am not. Instead of defining the function, storing it into a variable and then return the variable, we can skip the variable part and return the function definition immediately. This looks a bit nicer to me and the performance is slightly better, but the other way, using the variable, is absolutely fine if you prefer it. They are basically identical. Let us now call the function. As its argument, I am going to define a new variable called now, which will hold the value of time.now.unixmilli. So again, the current timestamp in milliseconds in a specific Unix format. Okay, pass in now to the timer function and store the returned value of the timer into a variable. Let's call it t. If we hover over t, you can see that it indeed is of type function, which takes no arguments and returns an int64. In the end, let's call t and print out the result. But before I run the code, let us once again go over what will happen exactly, because it's kind of a bit tricky. First, the timer function will be called with the current timestamp as its argument. This will return this anonymous function right here, which we store in the variable t. Afterwards, t will be called, which in turn will actually be executing the anonymous function and calculate the difference between the end and the start timestamp and return the result, which we then print out. Now let us run our code and see what happens. Okay, it returns 0. Let us change that. We can use the sleep function of the time package to let the process sleep for a specified time period. I will simply let it sleep for 200 milliseconds. If I run the code, you can see that it now prints out a value that is slightly above 200, which is fine since it takes a bit to process and call everything. The code seems to work now, but there is one thing I would like to change, and that is the function argument. What if we, instead of defining the start time as a parameter, define it within the timer function? This way, whenever we call it, we automatically set the starting time to the current timestamp. That has one big advantage. Let's say for instance we would add a second timer, let's call it T2, after the sleep function. The second timer, T2, will have its own value of start, which will be after the 200 millisecond sleep duration. So if I sleep for 200 milliseconds again and at the end of the function call both timers T and T2, we should see one time difference of a bit more than 400 milliseconds for T and one time difference slightly above 200 milliseconds for T2. Let's check that. Go run main.go, enter, and see exactly what we expected. Awesome, right? Keep this in mind because this is a very important thing. Every timer has its own value of start, even though you call both timers at the end of the main function. Oh, speaking of the start variable, just for reference. If you have a look at the timer function again, you can see that the anonymous function uses the start variable within its function body, even though it has been defined outside of the function definition and has not been passed as an argument. Anonymous functions in Go can actually do that, and if they do, they get a special name. Anonymous functions that use variables from outside their function body are called closures, just for you to know. That is basically it for functions returning other functions. The example I used is extremely useful if you want to know if your service is behaving correctly. I am actually using a function that is very similar to the timer function in many of my services I'm running in production. Instead of printing the difference out, I'm sending it to a database that serves the purpose of storing time measurements. Let's say for instance, instead of sleeping 200 milliseconds, you would first call a different service and then make a request to the database. Now, when I store these time differences every single time, I can see if a call to the other service would take longer than usual. Imagine it would usually take 100 milliseconds to retrieve the data from the other service, but now we have some connection issues and it now takes 500 milliseconds instead. I would now be able to see the spike and have to figure out why this happens. Okay, sorry for drifting off a bit. I just wanted to point out that this function is a real-world example, and a quite useful one as well. And that is it for functions. Not only are they very useful, they are also very powerful in Go. So make sure that you fully understand everything that I told you today. If you enjoyed watching this video or learned something today, please give this video a like and subscribe to the channel if you are new. It helps me out so much. It takes me roughly 25 to 30 hours to create one video, but it only takes you a couple of seconds to... So please do it. And the best for last, until next time, keep on coding.